Good morning, good afternoon, good evening, everybody. Thank you very much for joining us for this very exciting next edition of Marine Money's High Tide Foundation sponsored webinar series. You know, our industry across the globe, as many of you would have heard again last week in Posidonia, has identified and is tackling perhaps the most important challenge of this or any generation, reducing our CO2 footprint, combating climate change. And with this edition of Marine Money's webinar series, supported by High Tide Foundation, whose commitment to combating climate change is helping shape the global dialogue, we're going to look closely at carbon capture aboard ship. Today, among the world's leading shipping companies, yards, banks, class societies, and coalition, it's common to have a serious discussion about the development of alternative green fuels, pricing the distinguishing molecular characteristics of a cargo from source to final destination, or green finance. And while these grand future designs and realities are being architected by some of the world's best and brightest, the real work has already started in the engine rooms, among naval architects, with the help of MIT algorithms, retrofits, advanced technologies, driven operational optimization, commercial and scheduling efficiencies. Each has a material and momentous role to play right now as we progress in the inexorable journey to net zero. Today, it is my extraordinary pleasure to introduce a good friend, Nikos Petrakakos, principal at Ursus Maritime Capital and a real champion of investment banking for the new solutions, who in turn will moderate a presentation from Eduardo Panziera, CEO of Ionada, one of the most important technical developments which provides the industry another weapon in its fight against climate change, carbon capture. While the industry works to reduce or avoid emissions, carbon capture will play a critical role. Thank you guys both for being here. I look forward to listening to you.
Thank you, Jim, and it's a pleasure to be here. So, as you mentioned, obviously, people have moved faster than we thought. A few years back, a lot of people were considering wind propulsion and all sorts of other, alternative fuels as too far in the future. We're talking a lot about LNG. That has changed. That the industry is already moving a lot faster than most of us were expecting. There's a lot of pressure mounting to do pilots, and alternative fuels are moving closer. But at the same time, one container ship, large container ship, needs about as much green energy as 140,000 homes, a small city. So alternative fuels, even though that is the next step, is not feasible, for the entire market, and it's also not feasible for the existing fleet. And unless we're expecting to scrap the entire existing fleet early, which is equally bad for the environment, we have to figure out what to do now. So some people might say carbon capture is just enabling the oil and gas industry. But I see it as we need an all of the above solution or approach. And carbon capture has to be part of it. We don't have enough alternative fuels now, and we won't have them for quite a long time. And it should definitely be within the retrofit approach. And there's a lot of technologies being developed on this, and Ionada and Eduardo are certainly one of the forefront of this. So, what do we do? There's some people are discussing carbon capture. There's the issue of what do you do with the captured carbon, which is 3 times the volume. You need 3 tons of carbon for every 1 ton of fuel. How do you store all that? Well, we're talking about alternative fuels in the same way, and hydrogen is 4.5 times, methanol and ammonia are 2.5 times the volume. So it's an equivalent problem to deal with. But carbon capture is something that can be applied on a retrofit basis to existing ships, which is really not that feasible for ammonia and methanol, even when all that is set up. So, using that as a way to set the stage, I guess, for Eduardo Panziera. He's the founder and CEO of Ionada, which develops a modular carbon capture solution for both the maritime and broader energy sectors and other hard to decarbonize sectors. He has 25 years of experience in developing emissions reductions. He's a chemical engineer himself, both in the maritime and automotive industries, and has developed this great team with a great solution. And Eduardo, I'll let you take it from here.
Thanks, Nikos, and thanks, Jim, for arranging this. I'm going to just share my screen and make sure this works. Are you able to see my screen?
Yes.
Perfect. Yeah, so I'm Eduardo Panzera. I'm the managing director of Ionada. We're a developer of modular carbon capture systems. So first of all, some recent traction from our side. Let me see if I can minimize this. Our focus in terms of recent developments, we're Halliburton through Halliburton Labs, sponsored a technology to develop it specifically for post-combustion carbon capture. Natural Gas Innovation Fund, its focus is on minimizing the impact of gases and on the structure of the land-based systems. But today's focus will be on our marine solution. First of all, Ionada is one of the first technologies and first companies to receive approval in principle for onboard carbon capture system. And we're going to go through two case studies. One is for short sea shipping for coastal vessels, and the second is for LNG carriers, where we see early adoption of carbon capture makes sense. But we also have other groups of including renewable fuels, where we use, for example, direct air capture, as well as other technologies to produce renewable e-fuels. But today's presentation, we're going to focus on onboard marine carbon capture. We're just going to quickly touch on the marine regulations. I think everyone's familiar with it. We know that they're driving the change in the industry. We'll talk about the market drivers, why carbon capture on board makes sense for the marine industry. I'm going to introduce our technology, our unique patented technology, which is hollow fiber membrane contactors. That's a technology we developed initially for marine for desulfurization, and now we're able to use that same technology platform for carbon capture. That allows us to definitely leapfrog many of our competitors and have a mature technology that'll be ready for the onboard marine carbon capture market. We're going to go into two case studies. The first is with short sea shipping, coastal vessels, where it makes a lot of sense. And Nikos alluded to that. One of the issues we have is with storage on board. So for shorter sailings, it makes sense. And then we're going to talk about LNG carriers, where the energy balance, and obviously with steam-driven ones, the high CO2 emissions have a very quick payback on that case. And then I'll provide some references as well on projects we've worked on in the past in terms of developing the technology. Why we're here today, we're here obviously to talk about the greenhouse gas emissions. We've all collectively agreed we're going to reduce those emissions by 50%. The switch to renewables is not enough, especially for industries that are difficult to abate, such as the marine industry. If we try to electrify a vessel that goes from Shanghai to California, the battery pack would be larger than the cargo hold. And that's a big challenge, not just with electrification, but with hydrogen and ammonia. Ship owners have two choices. They can either install some sort of onboard carbon capture or pay increasing carbon taxes. And today's presentation will focus on how onboard carbon capture can help reduce your compliance costs. We see carbon capture as part of a whole plethora of unique tools available to the ship owner. There's improvements, and many of the ship owners have already implemented these reductions. For example, speed reductions to reduce greenhouse gas emissions, hull coatings. These are all great, but they're going to get us about 15 to 20% on the way there. If we're going to hit our 50% targets, we believe you need some sort of onboard carbon capture. And that's what we're going to talk about today. Obviously, the legislation is driving this. It's ever changing. I won't get involved in that, but there is a history of these changes. But what's unique about this industry now, I was also in the desulfurization industry. Desulfurization was really driven by the fuel costs. In this case, it is the Poseidon principles and the charterers. Companies like Cargill, ADM have all made pledges to carbon reduction. And now they're turning to the ship owners and asking, what are you going to do about reaching our target objectives? So it's really driven by the charterers, not necessarily by the ship owners. And what we see emerging is obviously as the technology emerges, our technology and our competitors, the cost of carbon capture continues to fall. We also see through the EU ETS and other global taxation, the cost of carbon pricing increasing. Vessels that trade within the EU are going to be included in the EU ETS, and that's going to have a significant impact on the operations. And when the carbon pricing exceeds that of the carbon capture cost, we see a break-even point. So our vision or anticipation is within the next 5 to 10 years, we're going to see an inflection point where it makes cost-effective business case to be able to do carbon capture on board. And this represents a $2 trillion market potential for carbon capture. Our technology, first of all, our competitors' technology, people who are familiar with carbon capture, they know these are very large facilities. They're typically doing 1 million tons and above of CO2 per year. They're $200-300 million. They take about 8 years to build. It's simply not a practical solution to have a 35-meter tower installed on the aft of the vessel. These typical towers need to be plus or minus 1.5 degrees. And that's not very applicable for marine application. In contrast, our technology, hollow fiber membrane contactors, allows us to shrink the technology down and marinize it. On the right here, we have an example of a small scale EOR, carbon capture system. It's a 500 kilowatts, but does show you how small it can get. This is for China oil field services for offshore application, but does show you how small the technology can be compared to conventional carbon capture systems. Key here, I'm not going to focus on the technology, is we have these hollow fiber membrane contactors. They have a very high TRL level. We combine that with proven amine solvents. They've been in the business for 70 years of doing carbon capture. The key here is we have a very high surface area per unit volume. This allows us to shrink the size of the absorber, gets rid of a lot of moving components, and turns the carbon capture from a chemical plant into an appliance you can plug into your engine and filter out the CO2. How it differs fundamentally is wet technology, for example, wet scrubbers or packed beds spray or atomize those solvents. Instead, we use these membranes to be able to capture and sequester that CO2. That's a very key attribute to our technology. The process flow diagram, it's quite simple. We take the exhaust gases, we pass it through the absorber. This is a renewable process. What happens is we load up these amines, we strip out the CO2, and then we can store it as a liquid on board. So that's a key in terms of the process flow diagram. What that means for our technology is more efficiency. That reduces the cost of carbon capture. We're able to modularize and containerize the system that allows us to really quickly deploy it on a vessel, helping reducing the dry dock and retrofit costs. And we're using proven reliable solvents. Our technology has been proven initially for desulfurization. Now we're applying it to carbon capture. What's this look like? This is our standardized modular system, 20,000 tons per year. That corresponds to about 85 to 90% carbon capture on a 4 megawatt engine. And we're going to see an example there later on for short street shipping, where one of these 3 40-foot high cube containers arrays is able to capture up to 85 to 90% of the CO2. It consists basically of an absorber, so the exhaust gases from the main engine pass over the absorber. We have a stripper that strips out the CO2, and then we compress and store the CO2 on board. I haven't shown the CO2 tanks because obviously that will differ on the application. But the key here is that if we want to do, for example, 25, these 3 40-foot high cube containers could do 25% of a 16 megawatt engine. Why would you want to do 25%? Well, we'll see, for example, if you need to achieve an EEXI or improve your CII rating by, let's say, 20%, then one of these units on a 16 megawatt engine would be able to get you compliance. If you want to do 85 to 90% carbon capture, you would have 4 of these units. And that's a modularity allows us to scale up quickly to be able to do anything from 4 to 16 megawatts. The OPEX will vary. We have here basically $18 to $46 per ton, and we'll explain that in detail, but it's about 5% increase in your fuel consumption. So if you're running this system just like a wet scrubber, you have an increase in engine load, and that corresponds to about 5% penalty. But if you look at the cost, for example, at 100 euros a ton, you're disposing the CO2 for 30 euros a ton, there's a 70 euro delta, and that's the payback, and that's the business model. And this typical unit uses about 400 kilowatts, and that's to run the compression system. So it's a quick note on the carbon capture technology itself. Company itself, as I mentioned, we developed the technology. We have Bureau Veritas approval initially for desulfurization technology, and now for the carbon capture version. We've run over 8,000 hours of the membranes on a ro-ro vessel, the Ionada, and this gives us a proven platform to be able to launch into carbon capture for marine vessels. We have a broad patent portfolio that protects the technology as well. We're not alone. There are many competitors on the market. Many of you are aware of companies like Mitsubishi, Air Liquide, Oxy, Aker Carbon Capture. But our key differential here is that the Ionada membrane technology, which is modular, the key challenge there is we double the size, we double the cost. And there's a break-even point, about 200,000 to 500,000 tons per year, where you're better to have a customized, tailor-made solution using, traditional carbon capture systems. But for marine vessels, they're all well below 200,000. That corresponds to about over 100 megawatts. Most marine vessels are between 20,000 to 100,000 tons per year. So definitely an advantage for our technology. It's also a much smaller scale, which makes it very easier to deploy on the vessel. So how we position the technology is we have the highest rate of return and lowest CapEx in the sub 200,000 market, which is what the marine sector is. One question that often comes up is, what do you do with the CO2 once you've captured it? We're going to talk about hub and clusters for sequestration. In the US and Canada, we look at EOR, but we also have an emerging market where we take the CO2 that's captured and produce renewable natural gas or methanol. So that's a key advantage to carbon capture, is there's a future value on that CO2. The Northern Lights is a great example where we see the hub and clusters being built out. You have these anchor tenants such as Norcem that are building out these massive infrastructure for CO2 and CO2 transportation. Well, this allows us, for example, for marine industry to be able to leverage these infrastructures, be able to then offload the CO2 into this pipeline network. And this allows vessels that come to shore, for example, the Porthos project in Rotterdam, any vessels trading into Rotterdam would be able to unload the CO2. And that's a key parameter we need to look at in terms of adoption. As the land-based systems build out this highway of CO2, the marine industry will be able to take advantage of that as well to dispose of the CO2. But let's get into specifics here and look at some examples. The first is with Grona Shipping. It's a short sea shipping. They deliver wood pellets from Eastern Europe to Copenhagen. In Copenhagen, they run, for example, a biofuel power generation. So that's net zero, their energy production, but the transportation is not. So they're willing to pay a premium for the transportation of low carbon or zero carbon. They've already looked at LNG as a way of getting 20 to 25% CO2 reduction. And now with carbon capture on board, we'll be able to achieve 100% net zero transportation. And that's really something that a charter, in this case, the power generation, wants to pay for. They're providing longer charter rates, higher charter rates, longer terms. The financing itself qualifies for EU financing at 2.8%. Over 7 years. And that's a significant advantage that shifts the economics from being, let's say, 5 years in the future to being economically sound today, because the charter is willing to pay for a higher premium for that application. In this case, it's about 3 to 4 megawatts, and we're able to do 85 to 90% carbon capture on board. We received our approval in principle for the project in December of 2021. And this project is a great example where the vessel only sails for 3 or 4 days. So we're able to store on ISO tanks the CO2, and be able to very easily offload that in a regular routine in terms of the shipment. So that's one of the issues we talked about, is obviously the challenge of onboard storage. In this case, these short sea shipping coastal vessels are ideally suited. In the case of electrification, anything more than 2 days doesn't make sense. These vessels sail for 3 or 4 days. That makes it a good business case for onboard carbon capture. The second application I'd like to talk about is LNG carriers. LNG carriers, many of the older vessels are steam driven, and they have a challenge with the EEXI. Their CO2 emissions per ton are much higher than other vessels or other combustion type engines. We looked at a study for a major energy company out of Norway, and we're able to demonstrate a strong business case for partial carbon capture. Because we're capturing about 30% of the CO2 on board, the amount of fuel we burn and the CO2 we gain is about the same. So the mass balance is quite positive. These vessels are also ideal because they have a very high quality LNG, flue gas. It's high temperature. We can use that waste heat to regenerate the amines. We also have a cryogenic storage or cryogenic cooler, which is the LNG, to liquefy the CO2. That provides a big advantage to look at, this application or any other LNG application for onboard carbon capture. What does that mean? If we look at the EEXI, the vessel is currently at 11.5. It needs to get down to 7.7. And that's a 33% reduction in CO2 to comply with the EEXI. Now, there's a boil-off factor that may be able to adjust that. But even with the CII, there's a challenge on these vessels. And also with other types of vessels, such as bulkers and container vessels. The advantage of doing partial carbon capture, let's say 30% on board, is we're able to shift, for example, from a D to a B or a D to an A. This allows us to be more compliant. And that's a big advantage that we discovered with this feasibility study we conducted with this energy major. And onboard carbon capture is not only viable, it makes a strong business case. This is what the technology looks like. In this case here, we have the vessel. We have 3 600 cube tanks on board, total storage about 1,800 tons. On the aft of the vessel, we install the carbon capture equipment. It looks very much similar to a backpack you would install on, for example, a wet scrubber. In this case, we have 2 of our 20,000 ton per annum units, so a total of 40,000 tons per annum. And this could do up to 75 tons per day of carbon capture. And this allows us to bring the EEXI into compliance and dramatically reduce the CO2 costs. In this case, the vessel trades from Norway to Spain and carrying LNG. Even at 30% carbon capture, the savings per year under the EU ETS is $3 million. Even if we factor disposal costs of 30 euros per ton, we're still saving 2 million euros in carbon taxes. And that's a big advantage. This is what the technology looks like in terms of the delivered package. We have the carbon capture equipment, which is on the aft of the vessel. We have the storage tanks, and we have a discharge system. In this case here, the advantage of this vessel, it comes into Hammerstead. Hammerstead has, for example, a facility for LNG and also has an acid gas well. So we can actually discharge in Hammerstead the CO2. That's a big advantage in this case where we have a built-in way of getting rid of the CO2. But I think it was very important. One of the key findings in our feasibility study for the energy major, that if we look at all the different methods to achieve the CO2 targets, we look at biomethanol, green ammonia, we even look at just paying the carbon tax. Using conventional fuels in combination with carbon capture provides the lowest cost of compliance. And that's a key finding from our feasibility study, that once we factor in the cost of carbon capture, it's still much lower than paying the carbon price and significantly lower than switching to ammonia or biofuels. At the end of the day, the regulators regulate emissions. They do not regulate fuels. And our vision is that onboard carbon capture provides the lowest cost of compliance to achieve those CO2 reductions. I've left examples on the projects here as well, but I'm going to skip down, running out of time for some Q&A.
Thank you very much, Eduardo. Yeah, so you covered a little bit on the cost difference between the alternative options, and I tried to mention at the beginning, that some of the issues we have between, let's say, hydrogen, ammonia, methanol, in terms of storage is what carbon capture has. How would you say, where does carbon capture play a role in this?
Yeah, so if we look at in terms of, especially if we're targeting about 30%, in almost all the cases we looked at feasibility studies, whether it's an LNG carrier, bulk or container vessel, 30%, it doesn't affect the stability of the vessel. And that brings us into compliance for the CII. So if you're looking at your fleet of vessels and you have a challenge with EEXI or CII, in our opinion, retrofitting the vessel with carbon capture is the easiest and most economical solution. Right now, there isn't a supply of ammonia or hydrogen, so that's off the table. Even if we compare it to biofuels and methanol, the cost of compliance is still much lower by simply doing onboard carbon capture. And once again, the caveat there is you often need to be trading, for example, in Northern Europe, where you have, for example, access to be able to dispose of the CO2. But for certain trade routes, it does make a lot of sense to do onboard carbon capture.
And at least for methanol, I guess you need CO2 in order to create the green methanol anyway. So
correct.
Might as well make it come from your solution. I guess open loop scrubbers faced some criticism in the past for on the SOx side. Your original scrubber design was a dry scrubber, so you didn't have that. How would you say the carbon capture side of things will face criticism potentially, and how do you get around that?
Yeah, obviously this is going to follow the same paradigm that we had with desulfurization. Nobody wanted a wet scrubber, but the economics are there, and we're going to see that happening. I believe my vision of the future is we're going to see basically two different charter rates: vessels with onboard carbon capture that have a better green rating and a lower cost, and vessels without. So for the ship owners that want to make the investment in the added equipment, their benefit is they're going to be able to charter for a wider range and for longer and better terms. And we see the same happening initially with, let's say, the LNG carriers. Already, some of the older vessels that are going to come off charter will not be charterable because they won't meet the new regulations. So the ship owners have a choice to make that investment in the technology or face the fact that they're going to have lower rates. So we see that kind of emerging, and that will drive the adoption, just as we saw with wet scrubbers. You're on mute, Nikos.
Sorry for that. Yeah, thank you, Eduardo. So one key point that you brought up is the modular nature of this. Obviously, that solves some aspects in terms of how it works with the lenders. You can actually lease this equipment and turn it into OpEx instead of CapEx. And you have a solution for that. Do you want to talk about that?
Yeah, so like one big advantage of a modular system, as you know, is it's not fixed to the vessel. So that in this case, let's say you're trading in Northern Europe and you want to reposition the vessel. Well, the benefit of the modular system is that it can be redeployed on another vessel. So if you have a sister vessel, you just simply swap out the carbon capture equipment. On the other vessel, maybe you switch to a renewable fuel. So they have some flexibility. And then from the financing side, working with people like yourself and URSUS, we're looking at the ability to provide lease financing. So that way we take this, capital cost and turn it into an OpEx. Our vision there is to, provide decarbonization as a service, where you just basically pay per ton. So for per ton of fuel cleaned, you pay a per ton fee. And this allows the ship owner to be able to, quickly deploy carbon capture on their vessels.
We've been seeing lately some other solutions out there that are coming out, that are basically a modified scrubber, able to capture some carbon, which I guess is similar to the original solution that you had that was able to capture 25%. How would you say that differs operationally, or in terms of where they fit in the market compared to what you can offer with the dedicated carbon capture?
Yeah, so with a big challenge we have, as you pointed out, is the storage. Once we've eliminated the storage, is the marinization of the technology, and that's going to go over a long curve. We saw that initially with the initial development of the wet scrubbers. There was a lot of learning pains, a lot of teething pains. One thing we know that with Ionada and our partners such as Halliburton, we bring a lot of engineering expertise. Our team are made up of naval architects and engineers. So I believe on the technical side, we have the depth that's required to install and deliver the technology. There's going to be obviously a rush to market, but my caution to ship owners is make sure and do the validation that you're buying a proven system. In our case, we've got thousands of hours of runtime. We've got case studies. So I think we need to be careful because we obviously want carbon capture to be success for everyone. I think there's not one company that can offer a magic bullet. But definitely be aware that it is an emerging technology, and you need to select the right vendor to supply that equipment.
Thank you for that. So in terms of the CO2, you mentioned you capture it, but what do you do afterwards? You mentioned the Northern Lights. I guess what are the ideal trade routes right now in terms of what's your ideal customer in terms of where they trade?
Thanks to programs like the Northern Lights, there's a fleet of CO2 carriers being built. And what we've seen, obviously, with pipelines is you have a limit of whatever, 700, 800 kilometers, and then it's more economical to transport. So we see over the next 5 to 10 years, a fleet of CO2 carriers being built out to transport CO2. For example, Shanghai, or for example, Singapore. Singapore has a challenge where there's nowhere for them to sequester it. So marine transportation of that CO2 from Singapore has to go somewhere. So marine transportation will then build a network, a highway along the seas to transport the CO2. This allows us now to bunker that CO2 off your vessel onto one of these CO2 carriers. So that for us is how we see this moving forward, is having this network of CO2 carriers and the marine transportation, because fundamentally, we talk about the impact of CO2, but marine transportation is the lowest carbon footprint. So if we're going to transport CO2 to sequester it or repurpose it, marine transportation is ideal. And now ship owners can use that network to discharge the CO2.
Thank you very much, Eduardo. Jim?
Well, I was going to say, yeah, thank you very much, Eduardo. That was a very impressive presentation, and very effectively put forward. Nikos, thank you also very much for introducing us to Eduardo and for your portion of running this thing today. I really appreciate it. So, and really on behalf of both Marine Money and the High Tide Foundation, I want to thank you both, not only for the webinar, but more importantly, actually for the commitments to our industry's sort of efforts to combat climate change that you're both making. And once again, I think it's an example of the industry's leadership and initiative. The replay of this will be available. It usually takes a couple of hours to get it posted to be on the marinemoney.com website in, as I say, in a couple of hours. Our next High Tide supported webinar will look at more of our industry's important incremental sort of efforts to meet net zero goals. And with that, I'd just like to say thank you again to Eduardo and to Nikos, and to say I hope to see all of you out there viewing this at Marine Money Week next week in New York City. Thank you all very much for your time this morning, and Eduardo, very continued great success in your business, and you too, Nikos.
Thank you. Thank you. Take
You
care.